calculate the ratio of theoretical super elevation to the actual super elevation if the equilibrium speed on the BG railway track, that is broad gauge railway track, is 100 km per hour. Okay, so here first of all we need to understand what is super elevation. Basically super elevation is provided especially on when we are encountering any curve, horizontal curve is there. So suppose this is your railway track, right? Just I am drawing so that you will be able to understand. Okay, just to counteract the centrifugal force, you have to raise this outer edge by certain amount. So this is your super elevation. Okay, so you have to raise this outer edge by some amount to counteract the centrifugal force. So these are your rails. Now theoretical super elevation and actual super elevation, the difference between two is known as your Kant deficiency. So obviously actual super elevation which you are providing, okay, that will be less than the theoretical super elevation. Theoretically you will get some value, let us call ETH, that is theoretical super elevation. So it will be mathematically, it will be actual super elevation plus Kant deficiency, right? So some deficiency will be there. Theoretically this value will be slightly higher. Okay, so E actual plus Kant deficiency will give you the value of super elevation, that is theoretical. Now you should remember one more formula, that is known as Martin's formula. I am just writing down. After that we will solve this example. Okay, so V is equal to 4.35 under root R minus 67. This is known as Martin's formula. And another formula for actual super elevation, that is E actual, that is GV square upon 127 R. This is very famous and very important. Both the formulas are important from exam point of view. Okay, so this is the concept. One more thing which you have to memorize or you have to remember, this is common sense. The value of G is 1.676 meter for BG track. So normally they will give you BG track only. If it is meter track, so it will be 1 meter. The value of G is 1 meter. And Kant deficiency, this value also you are supposed to remember, that is 7.6 centimeter. So this value is specifically for BG track. Okay, now here the equilibrium speed, they have given velocity, that is 100 km per hour. So just put this value in Martin's formula. So substituting V in Martin's formula, you will get 100 is equal to 4.35 under root R minus 67. So here radius R, you will get around 595.47 meter, right? Now substitute this value in the formula of super elevation. So E actual is equal to this formula. Let me write it again. GV square by 127 R. So G is your 1.676 multiplied by velocity. Here directly you have to take into kilometer per hour only. So 100 square divided by 127 multiplied by R value we have just found out, that is 595.47. Okay, so actual super elevation you will get somewhere around 0.2216 meter. Okay, so convert it into multiply by 100, so you will get 22.16 centimeter. Now we know Kant deficiency and we know actual super elevation, right? But one more thing, just remember, for V less than 120 km per hour, see this you have to remember, we have velocity 100 km per hour which is less than 120, kilometer per hour for BG track. E maximum actual super elevation maximum value, that is 16.5 centimeter. So now this value is for velocity less than 120 kilometer per hour and for BG track. Okay, so now we have to take this value. Okay, E actual, we should not take this 22.16 centimeter, we will take this value 16.5 centimeter. So that's why I am writing adopt E actual is equal to 16.5 centimeter. Okay, so you have to be slightly careful and you have to remember this criteria, because our velocity is less than 120 kilometer per hour. So our super elevation maximum value is 16.5 centimeter. So now let us write on take this formula, that is E theoretical is equal to E actual plus can deficiency. So actual super elevation, the maximum value which I have to take is 16.5 centimeter, and can deficiency which I am supposed to take the maximum value again, that is 7.6. So it is 24.1 centimeter. So this is the theoretical value. Okay, now what they have asked, see the question is calculate the ratio of theoretical super elevation to the actual super elevation. Okay, so basically they are asking ETH divided by E actual. So ETH, just we have found out, that is 24.1 centimeter divided by actual, we are supposed to take 16.5 centimeter. So centimeter cut, so it will be around 1.46. The ratio is 1.46. Okay, thank you very much.